In this video, I'm going to solve a couple of examples based on the light ray. Here is the first example. A light ray leaves point A, reflects from the mirror, and reaches point A. So here he's talking about a light ray starting from A. A is right there, and it is starting from A and reaches to the mirror and reflected back and reaches to point B. How far below the top edge does the ray strike the mirror? So he gave us the total height of the mirror and some other distances. Okay, so all we know is law of reflection. We're going to use the law of reflection formula to solve this. According to the law of reflection, if a light ray, so if here is a surface, if a light ray strikes the surface with an angle of theta I, the theta I is always between the normal and the light ray. So the red color is the normal, this is normal, and the white one is light ray. So when a light ray strikes the surface with an angle of theta I, it reflects with an angle of theta R. Okay, so according to law of reflection, theta I equal to theta R. So here what I'm going to do, since theta I equal theta R, I'll try to find what is theta I. So I'm going to take the question he's asking about. He is asking us to find this H value. Find the H value, height of the mirror, not exactly total height, where the light ray strikes, from the top edge to the where the light ray strikes. So I'm going to take this triangle. Look at this triangle, the top one, theta I. Can I take that tan theta I equal to opposite over adjacent? Opposite, I'm going to take that as h minus 5 centimeter divided by adjacent is 10 centimeter. That is given. So adjacent length is given here, right there, 10 centimeter, and the height must be h minus 5. Same thing with the tan theta r. Tan theta r, here I'm going to take this triangle down here. Okay, so if I take this triangle, this must be opposite over adjacent. Opposite must be 15 minus h, and the remaining height, that's 15 minus h, that's the opposite side, and adjacent must be 15 centimeter. That is given right there. Okay, so if theta I equal theta r, tan theta I equal to tan theta r, since both the angles are same. So h minus 5 divided by tan equal to 15 minus h over 15. Okay, I'm going to do the cross multiplication. So 15 times h minus 5 equal to 10 times 15 minus h. So 15h minus 75 equal to 150 minus 10h. Okay, so if I solve this, we'll end up with 25h equal to 225, h equal to 225 divided by 25, which is 9 centimeter. So the light ray is going to strike 9 centimeter from the top edge, 9 centimeter below from the top edge. Okay, that's the first problem. The first problem is based on the law of reflection. Here is the next one. An underwater diver. Here is the next example. An underwater diver sees the sun ray at a 50-degree angle above the horizontal. So all he gave us, here is the diagram I draw. Here is the water, and the pink line is the normal. Okay, that is normal. Now he gave us, and the orange one is the light ray. He gave us the angle between the base and the light ray as 50 degrees. Okay, so how high is the sun above the horizon to a fisherman in a boat above the diver? So the question he's asking about, there is another fisherman just standing above the water level in a boat. So what is the angle between the light ray and the fisherman? Between the light ray and between the light ray as well as the water, or between the light ray and the water. That's what they're asking for. Okay, so here we're going to use the Snell's law. Okay, we know that when the light ray traveling from one medium to another medium, so here the light ray is traveling from air to the water, so those two are two different mediums. The speed of the light ray is going to change. Okay, so we can find out that value by using Snell's law. So according to Snell's law, n1 sine theta 1 equal to n2 sine theta 2. Okay. N is nothing but the index of refraction, and n value for water is 1.33. Okay, you need to remember that number, and n for air is 1. Okay, so I'm going to take the theta 2 in this case. My theta 2 equal to, if you look at this triangle right here, that's a triangle, so 90 degrees here. So if I have 50 degrees there, theta 2 must be 40 degrees. So n1 sine theta 1, n1 equal to 1. I don't know what is sine theta 1. Let me leave it as it is. And n2 equal to 1.33 sine theta 2, theta 2 equal to 40 degrees. So based on this, I can find sine theta 1. Sine theta 1 equal to, this value is 0.854. So theta 1 must be sine inverse of 0.854. That equal to 58.74 degrees. So theta 1 is known. Now theta 1 is the angle between the light ray and the normal. The goal is we want to find theta here. The theta here is same as the theta here. So how can I find the theta? Theta must be equal to 90 minus theta 1. So I already know what is theta 1 is, 58.74. So theta must be 90 minus 58.74. That must be equal to 31.25 degrees. This is what they're asking for. I'll stop this video here. In the next video, I'll solve a couple of more examples. Thank you.